Namaste. Welcome to our channel. Welcome to another educational episode on civil engineering surveying. My name is Ajay and I am the Director of Precision Surveys India Private Limited. We have our offices in Bangalore and Hyderabad. So today we are going to deal with the topic of DGPS surveying. So you would have heard about this probably online or somebody saying it. So basically, DGPS, or rather, you would have commonly heard GPS, something called as Global Positioning System. In surveying, we use Global Positioning System, but with a difference. So the difference I'm going to explain right now. The equipment that we use for positioning is called as Differential Global Positioning System. So all of you may be aware your phone has a GPS device, or you're going on. You can get free, GPS devices when you're going trekking and all those things. People use like Garmin and different people produce these GPS based what do you say positioning. It's used for mapping techniques. Like your Swiggy works on the similar principle. Google Earth, Google Maps, all those things works on the similar principle. So any point on a globe, its position can be defined by X, Y, and Z axis. So basically that is represented in a global positioning system in latitude, longitude, and elevation. So these 3 points, if you have, you can go and identify a particular point. So now we move on to the applicability of how this DGPS equipment is suitable in the field of civil engineering. One more precursor to that is global positioning system. In civil engineering aspect, when it comes, we use a differential global positioning system. The difference is in a global positioning system, on your example on your cell phone, or wherein you use the maps, the signals that are received are only L1 signals. That is the global positioning system, that is WGS 84 coordinate system, which is was developed by the big brother, that is USA. So they follow the WGS 84 coordinate system. Then there is this nothing but a constellation of satellites which keeps circling the globe, and these constellation of satellites provide the position on a particular point on Earth. Basically, the communication happens between the receiver on Earth and the signals from the satellite. The signals from the satellite are short. They continuously emit signals, that is L1 and L2 waves, whereas your phone will receive only the L1 waves. So basically, the position of a particular point on your phone is off by say 10 to 15 meters. However, when it comes to differential global positioning system, the equipments are expensive. It goes lakhs together, 18 lakhs, 20 lakhs for a couple of receivers. The advantage of the system is both L1 and L2 waves are relayed, and this receiver is capable of receiving both the waves. And the advantage is to the nearest millimeter on a global scale, on the entire Earth, on the entire globe. Wherever a point is, it can be defined to the nearest millimeter. That means today I am standing here, I am doing continuous observations. This particular receiver that you are seeing on your image on your screen, this is the receiver. This receiver receives both the L1 and L2 signals, and this receiver is mounted on a tripod. And the advantage of this tripod is the particular point can be marked on the ground, the point to the nearest millimeter. So this receiver receives both L1 and L2 signals, and for the receiver to function efficiently, a minimum of 4 satellites has to be visible, because speed is equal to distance traveled by time taken. So in that equation, there are the speed, distance, and time. Speed with which the satellite is traveling, distance we know from this particular point to that particular point, time taken, that variable also a particular time taken from moving point to point A to point B. An additional fourth satellite also is necessary to identify the particular accurate position of that particular point. So this particular processing happens even in your phone as well. However, the positioning accuracy is more accurate in a differential global positioning system, which is appearing on your screen. Now let's move on to the application part of the DGPS equipment in the field of civil engineering surveying. See, earlier, as I told you in the earlier videos, the land costs were cheap. Therefore, any position 10 meters, 5 meters moving here and there, because it was basically agricultural land, not too much value those days. nobody bothered. But nowadays, when the land costs have shot up, gone through the roof. Like example, in you take Hyderabad city. Suppose there is a road expansion of an existing road. So now you need to define how much land area has to be, what do you say, acquired for the road, proposed road expansion. Now you have to provide compensation to the landowners, and there should not be a claim after you fix your expansion. What do you say? As per your design, you fix what is the expanded area that's supposed to be acquired. These particular points can be defined to the nearest millimeter on a global scale. The advantage is tomorrow, even if these boundary points are moved, even by say somebody, over a period of time, these boundary stones are removed. But the advantage of global differential global positioning system is you can go and retrace that particular point, and this can be recorded in your property documentation as well. The same applicability, imagine in your property. Your property is defined by a boundary. However, you do not have a global coordinate system. So tomorrow, after 10 years, 15 years down the line, your neighbor encroaches into your property because you're not able to, be there on site every time. So then how do you go back and reclaim your property? You can reclaim if you are if you have geotagged the property. Your latitude, longitude, and elevation is completely defined for all the boundary turning points. Then it's simple. Even after 10 years down the line, go back, place the same equipments, go and retrace that particular point. So you'll get back your original boundaries. So that is one of the applications of using DGPS in your civil engineering surveying line. Another advantage is elevations, that is the mean sea level values. So every project site, say big project site, and it's a high-rise building or an industrial building, they need to take a clearance from the Airports Authority of India. The reason why we need a clearance from Airports Authority of India, because your buildings cannot go too high, because it should not be in the path of the flight. So example, an airport has a runway flight path, that is runway threshold points. From there, it is calculated for up to 15 kilometers distance along the edges of the runway strip, and also on the parallel to the runway strip, there is a glide path within which there are certain height restrictions wherein the buildings cannot go beyond that height, because it's an approach. If it goes beyond a particular height, it is obstructing the glide path of the particular aircraft for taking off or landing, and security issues. Hence, Airports Authority has to issue an NOC, and they have certain parameters based on which they'll issue. For issuing NOC, they need a latitude, longitude, and MSL value certificate of a particular point. The whole globe in DGPA Differential Global Positioning System has a coordinate system. That is the latitude, longitude, that's called as WGS84 coordinate system. There are several coordinate systems based on which country has launched their own satellites. um, Similarly, there is the UTM, that is when you should have heard this also, Universal Transverse Mercator System. That is this global positioning system. You see, it's a globe, it's projected onto a plain, flat piece of paper. When a globe, which is a circular shape, it is cut out, and imagine making it into a flat surface, there are certain corrections, because all these curvatures on the globe needs to be corrected for aligned, and then corrections need to be applied for those. So that applied system is called transverse Mercator system. In addition to that, there's another concept called as local TM system that will come in the part of total station. I shall explain to you about that later. However, a basic understanding of using DGPS is what I have explained to you right now. Hopefully, this has shed some light, and we shall keep giving you more such videos. Please like, follow, and subscribe to our channel. Thank you.